All right, 4.3 notes, solving absolute value inequalities is where we're at today. So, key things here. When you have absolute value inequalities, you have two types of absolute value inequalities.
First type that you have right here is a less than.
Okay, that also applies to the less than or equal to. But you have a less than type of inequality. And what that means is that you've isolated your absolute value completely by itself, and you're left with less than a. Okay, what this is saying is that the distance from x to 0 is less than a certain amount of units. So what that looks like graphically, it's saying that here's 0, or here's that number, whatever the number is. But here's 0, and it's going to be a joint inequality. So it creates a joint inequality. So from some number to some number is your solution. Okay, you can write it separately, but there's no real reason to write it as an and statement. But if that's what you wanted to, but your answer should be written like this. Okay, the next type of inequality, absolute value that you can have is a greater than. This also applies to equal to, greater than or equal to. And what this is saying is that the distance from x to 0 is greater than some amount of units. So when you look at it graphically, notice how our arrows are going outward instead of inward, right? So this is a compound solution. It's an or situation. Either x is less than negative a or x is greater than positive a, but it's an or situation. So when you have a less than situation, you're going to have a joint solution. When you have a greater than situation, you're going to have a compound solution. So you have to pay attention to the inequalities. All right, we're going to go through the steps. So the steps to solve an absolute value inequality is to isolate the inequality. Then you're going to set up the two inequalities. So depending on which one you have, so if it's a less than, then you're going to set up where you're solving a compound
In a joint
solution.
And if
it's greater than, then you're going to set up where you're solving for a compound. And then you're going to solve the inequalities. And we're going to graph the solutions on the number line. All right, so let's dive in. So the first one we're doing together is that it's a less than, right? So our we do here is a less than. So since it's a less than, we know that we're going to have a joint inequality. Okay, so step one is to make sure that your absolute value is isolated. That means there's nothing around it. When I look at my absolute value, there's nothing outside of the absolute value lines. That's good to go. Step two is then to create your equation, your inequalities. And because we know it's going to be joint, because it is less than, what that looks like is you have your absolute value. So you remove the absolute values. So we have 2x minus 1. And it's joint. So we have it less than positive 5 and greater than negative 5. And that's because it is a joint. And now we're going to solve for x. So what do I need to do to get x by itself for step 3? Or subtract. What about this guy? That minus 1. Okay. I have to add the 1. When you're working with a joint inequality, you're going to do that to both sides of the inequality. So I have to add 1 here and add 1 here. So it's like you're working 3 things at a time. So you have -5 plus 1. If you owe me $5 and you give me $1, how much do you still owe me? 4. Here, I'm left with 2x. And 5 plus 1 is 6. Now what do I do? Now I can divide. Once I'm down to the multiplication, then I can divide. And again, you have to do it to every side of the inequality. So we have -4 divided by 2. A negative divided by a positive is a negative, and 4 divided by 2 is 2. Is less than x. And then we have 6 divided by 2 is 3. So here's my solution. So what this is saying is, in order for this to be a true statement, x has to be less than 3 but greater than -2. So on a number line, it asks me to graph, it says to graph the solution. I'm going to graph my solution. So I have -2, I have +3, and they're going to be open circles. The reason why they're open circles is because they're what? Strictly less than. It's not included. You remember that from Algebra 1? When you have strictly less than or strictly greater than, it's an open circle or a dashed line situation. How do we feel about the weeded? Okay. All right, so you're gonna try a lesson on your own. So here's your lesson. What is the solution of absolute value? 3x minus 4 is less than or equal to 8. If you need help, this is where you ask for it. It's still a joint. It's still a joint because it's less than. Good job. It's still a joint. They're fractured, it's okay.
4, good. And you divide by 2. Add 4. Well, this is the thing. Take one negative, one positive. Yeah.
No.
$12 or one kid, $4. But you did everything right.
All right, people. Let's go over it. All right, so step 1 is to make sure it's isolated. Is it isolated? Yes. Step 2 is to set up our joint inequality. So we have 3x minus 4, and it has to be less than or equal to positive 8, but greater than or equal to negative 8. Okay, step 2. Step 3 is to get x by itself. So in order to get x by itself, we're gonna add 4, right? We did good. So this is negative 4 is less than or equal to 3x, less than or equal to 12. And then we divide by 3. And remember, fractions are our friends. So we leave them alone. Negative 4/3 is less than or equal to x, which is less than or equal to 4. Because 12 divided by 3 is 4. How we do? If you were to put it on a number line, you would have 0, you would have negative 4/3, you would have 4. And on the number line, these would be closed circles. Because if we remember, when you're equal to, that's a closed circle. And that would be your solution on the number line. Good, bad, okay. All right. Now we're gonna do greater than, okay? So with greater than, that means we have our compound solutions, right? They're separated. So the same first step is to make sure that it's isolated. Is it isolated?
Yeah.
Yes, we don't have to add or subtract anything away. Step 2 is to create our equations. You're creating 2 equations with greater than. So you're going to create a less than equation with a negative. So we end up with 2x plus 4 is actually less than or equal to negative 6. And then you're going to create the greater than equation. 2x plus 4 is greater than or equal to positive 6. And you're going to solve both of them. With greater than, it creates a compound called the or statement here. So we have 2x plus 4 is less than or equal to negative 6, or 2x plus 4 is greater than or equal to positive 6. And now we just solve. So the setup here is a little different, but the solving is still the same. After 2 comes 3, not 4. So what would I need to do to get x by itself? Subtract and then do what? Divide. So our plan is to subtract and then divide. So we subtract 4. And we're left with 2x is less than or equal to. If you owe me $6, you're like, hey, let me borrow another 4. You now owe me $10. Like you said, we're gonna divide. And that gives me x is less than or equal to -5. The exact same thing I did here, I'm gonna do on the other side. So again, we're getting x by itself. We're gonna subtract 4. And we get 2x is greater than or equal to, you have $6, but you go spend $4. So now you have 2. And then we divide it by 2, and 2 divided by 2 is 1. So this is your answer. X is less than or equal to -5, or x is greater than or equal to 1. Every time you have a greater than, it's going to create a compound. So on a number line, see, I have 0, 1, -5. Are they open or closed circles? They're closed. And instead of being joint, they are heading in the opposite direction. All right, what are your questions about greater than? So you're going to create a less than and negative. And you're going to have a greater than and positive. All right, here you go. Your turn. I'll be walking around.
Come on, both of them get it right. No, I'm both gonna get it right. I believe in you.
And we're creating 2, a less than with the negative and a greater than with the positive.
It's okay.
Think of a less, like a less than, kind of looks like an L, right? Less than symbol, kind of looks like a less. There you go. And then you solve that one. The other one. I don't know why you do that one. That's greater than. The greater than the other way. Yeah. That way. The way you have to do. There you go. How are we doing? Set it. Which of it? 15. It's -25. So it's like you owe me 15 and then you owe me 10. Now you owe me 25. No, I haven't done it yet. I'll do mine for tomorrow morning or now. Monday grades are not my thing.
I'm not in the butt.
I was like, you're not done yet. All right, 2 more seconds. All right, geniuses, let's see how you did. Step 1, do we have to do anything to isolate? No, we're good to go. Step 2 is where we create our 2 equations, right? So we had our 5x plus 10 is less than -15, or 5x plus 10 is greater than 15. Doesn't matter which one you solve first, just as long as you solve them. In step 3, is to isolate the x in each one, right? So our 2 steps, we subtract, then we divide, right? So we subtract 10. And we're left with 5x is less than. And if you owe me $15, you're like, hey, let me borrow another 10. You now owe me 25. And then we divide by 5. So we get x is less than -5. Or, again, we're going to follow the exact same steps. Subtract 10. Now when we subtract 10, we get 5x is greater than 5. Then we're going to divide by 5. And 5 divided by 5 is? Yes. So our answers are x is less than -5 or x is greater than 1. How do we do? So if I had to graph this on a number line, we would have 0, -5, and 1. You have open or closed circles? Job. Open circles. And my arrows are going where? Out. Good job. Yes? How are we feeling? All right, cool. All right, last piece is our special cases. All right, so special cases. If these things happen, then your job is easy, okay? So the first one we have here is if you have a less than situation, whether it's less than or equal to or less than or greater, less than or equal to or just less than. If you have the absolute value is less than or equal to a negative, that is a no solution. That reason being is positive numbers are never less than negative numbers, right? Positive numbers are never less than negative numbers. So the final answer would just be no solution. So if you ever had where it says less than and then a negative, your result is no solution. Can you handle that? All right, let's talk about our special cases with the greater than. Okay, if you have an absolute value is greater than or equal to a negative, if this happens, that's true. That's gonna always be true. Always be true. And the reason why is because positive numbers are always greater than negative numbers. So this is infinite solution. So less than a negative, no solution. Greater than a negative, infinite solution. Okay, at the bottom you should have enough room to write in. Oh, I thought I was gonna have. But another, if it's equal to, if you have an absolute value that is equal to a negative, that is also a no solution. If you want to add that in there. If it's equal to, then it is a no solution. The reason being is that absolute value is our distance, right? How far are we? And can we have negative distance? No. Therefore, it's no solution. All right. That concludes our notes. How do we feel? Good? Awesome.